Abe B. Black. By the way, this is Dr. Angelbert Morales, your tutor teacher for today's episode. Our today's episode is about normal distribution, finding areas from values. To start with, let's dive into today's target or the objectives. Objectives for today are as follows. Find the proportion of values to the left of the normal boundary in a normal distribution. The second one, find the proportion of values to the right of the boundary in a normal distribution. And lastly, we have find the proportion of values between two boundaries in a normal distribution. To start with, let's go with the example. We are going to recall that the distribution of the ITBS vocabulary scores among all Gary, Indiana 7th graders is approximately normal with a mean of 6.84 and standard deviation 1.55. What proportion of these 7th graders have vocabulary score that are below 4th grade level? Meaning it is less than 4. If you still remember our discussion on finding the areas of a normal distribution, we put this area on the left side because of the word less than 4. So we get the values of the normal number line by simply adding and subtracting it with the standard deviation. So we start with 6.84 and then we add 1.55 to the right to get 8.39. Next, we add another 1.55 to the right to get 9.94. Then we add again 1.55 to the right to get 11.49. On the other side, on the left side of the mean, because this is our mean, we subtract 1.55. So from 6.84, we subtract it to 1.55, we got 5.29. Then after that, we subtract again by 1.55, so we got 3.74. Then we subtract again 1.55, so we got 2.19. Alright? So that's the reason how we come up with this number lines scale, no? So we get it from the mean and the standard deviation. Then, after having the allocated numbers, we put the 4 on its position. We know that 3.74 is quite near to 4, so that's why we put the line here along 3.74, and then we shade it to the right. Again, we shade it to the left, sorry. We shade it to the left because it is less than 4. But if the statement is greater than 4, then you have to shade the right side. Okay? So what we going to do is, of course, we do the allocations of the points along the number line. So we have to do the calculation to the right and to the left of the standard deviation. Then we get we use the formula of the z-score. Okay, in the chapter 2.3, we discussed the z-scores already, and the formula for that is value minus the mean all over the standard deviation. In mathematical symbol, we got here the x minus the mu over the omega. All right. So then, the next step is, if the quantitative value we standardize as an approximately normal distribution, then so that's the new variable z. So meaning, even though we got another z-score and you saw that it is normal, in normal distribution, we still have the normal distribution. Okay? So, but during the time when we got the z-score, we call it standard normal distribution. Okay, so earlier we used the original value, or what we call given value, because those are the unstandardized normal distribution. So in the standardized normal distribution, the only difference is here. We got the mean 0, standard deviation 1. So that's the difference between the two. We got the mean 0 and then the standard deviation 1. While in the unstandardized, we use the given value of the mean and the given value of the standard deviation. Okay, so if we're going to discuss standard deviation, we can say that it is the normal distribution with mean 0 and standard deviation 1. So this is the perfect presentation of the normal distribution. So of course, we started with 0, then we got 1 on the right side, and 2, 3. Okay, and then the other side, -1, -2, -3. As you can see, guys, we have the unstandardized picture of our normal distribution. So after having this graph or picture, we calculated the z-score. The z-score now will be, the 4 is the value, no? And then we got 6.84 divided by 1.55. All in all, the final answer will be -1.83. Okay? So, we represent that in the another graph. As you can see, we have here the right side, then we got -1.83 here. As you can see in the figure, they are totally the same. Okay? The only difference there is the number line. Okay? So, the difference, we can say that this one use the z-score, while on the left side, we use the given score or the row scores. Okay? So, upon calculating the z-scores, we can represent our normal distribution in this manner. We use that 1, 2, 3, and -1, -2, -3. Alright? So, that's the difference between the two. By the way, we call this unstandardized. And this one, the right side, is standardized. Okay? So after having the value of the -1.83, we use a table. Okay? So in my table, I got -3.6. Okay? But in our given here, it's -3.4 because this is from the book. Okay? This is from another book. And then I also, in my class, I usually give them this one printed, no? So this is free for my students, okay? So the next step, so we go into the -1.83, okay? So what we do is we get the 2 digits first, -1.8. The -1.8 is on the first column. Okay, it's in the first column. The next one, the 0.03. So because we got 1, 2, 3, the third digit, no? So the third digit, but of course you have that 0, no? Okay, so we got 0.03. So the 0.03 is on the top of the table. So all in all, if we're going to do that in summary, so we got the -1.8 here, and then 0.03 on the right side, on the top. Okay, then once they meet, so we got that answer as our percentage area. Okay, so we got 0.0336. So that's the percentage area. All right. So we estimate that about 3.4, actually that's 3.36, no? Of Gary Indiana, 7th graders scored below the 4th grade level on the ITBS vocabulary test. Okay. In our class, in my class, they use applets. So you can download it, ST Applets, on the website, and then you can plug in, you can see this. So the next step for my class, the next step will be, you go to applets, click normal distribution, okay, then make sure that on the operation, you got calculate an area under normal curve. Then, you type the mean 0, then the standard deviation 1. Then click the button, plot distribution, and this will appear. Alright? So this picture will appear. Alright? Then, after that, calculate the area, make sure it is to the left of the value. Okay? Then, type the z-score value, or the value, negative 1.83. Then, the area will be 3.36. The same as on the table. Okay? So, we got 3.36 on the table, we got 3.36 on the applets. There's also another way to calculate it. We can also have the calculation of this in a calculator. Okay? So, in the calculator, you simply type normal CDF, close and open parentheses, negative 1,000, negative 1.83, then 0, and then 1. So the answer is still 3.36. Alright, so the same. So whether you use the calculator, you use the applets, you use the table, they are all the same. But of course, there are very minimal difference. There is still some minimal difference. Alright? The next step, because we want to prove that they are the same, okay, we're going to calculate it on the unstandardized score. Okay, unstandardized score and the unstandardized normal distribution. Earlier, we do the standardized normal distribution. So still we got normal curve. So but this time the mean is 6.84. Then the standard deviation is 1.55. Then click the button, plot distribution. Then you got this. You will see this figure on the applets or ST applets. So then make sure that to calculate the area to the left because we are on the left. Okay, to the left. Then you type 4 for the, for the value. So after putting the 4, you click calculate area and then you will see 3.35. Earlier, we got 3.36. Okay, from applets and calculator as well as with the table. Now, using the unstandardized value, we got 3.36. So all in all, they are closer at 3.35. No, this is 3.35. They are much closer. No, a little bit different, but they are the same. All right. Next one. So we already done with the normal finding the proportion of the values to the left of the normal distribution. Now we go to the procedure. So actually, I'm not going to do this anymore with the procedure because I know that you know it already because actually the first procedure is you need to draw the line, put the normal curve, and then get the mean, what's the value of the mean, add to the right, subtract to the left of the standard deviation, having standard deviation value. So that's the only thing that you need to do. All right? And then shade. Of course, you have to be very careful. If it is to the left, if it is less than, it's to the left. If it is greater than, it's to the right. All right? So we got here a problem, no? A problem with Martha, no? So many studies on automobile safety suggest that when automobile drivers must make emergency stop, the stopping distance can be modeled by a normal distribution. Suppose that for one model of a car traveling at 60 miles per hour under typical conditions on dry pavement. Dry pavement meaning this happened during summer. Alright? So, the distribution of stopping distance is approximately, okay, with the mean So, as you can see, so we got approximately with the mean 165 feet. Standard deviation, we got 4. Okay? So again, the mean is 165. Then standard deviation 4. So now, Martha is driving cars when she spots an accident. Okay? 170 feet in front of her. And needs to make an emergency stop. Oh my God. So Martha will be Martha see the incident, and during the time, it's 170 feet away from her. Okay? The question is, about what percent of the cars of this model will be able to make an emergency stop in less than 170 feet? So in that case, we from 170, Martha should not hit the distance from 117. So we are going to check how many percentage of chances that she's not going to hit the incident, no? That car who have accident. Okay, so that's the one that we're going to do now, no? We're going to calculate the percentage. Okay, next. So, about what percent of a car model will be able to making an emergency in less than 170 feet? So the first thing first, we need to draw the line. Okay, put the data and then make a normal curve, calculate the number line, and then we got 170 here. So because less than, it's to the left. If it is greater than, it's to the right. Okay? So this is less than. Okay? So that's why we shade this. Okay? So if it is greater than, again, we're going to shade the other one, not on the left side. So we're going to shade the left side because it is less than 170. Now, after having this drawing and or picture, we calculate the z-score. So from the z-score, we got 1.25. Guys, I'm not going to read this anymore because I know that you know the z-score already because we discussed that before, no? You did a lot of problem set using z-score. All right? So next, so having the 1.25, so you get your table, transmitted table. So we got that in the second page. Positive is on the second page. Okay. So we got here 1.2 first, and then 0.0. So you look for the 1.2 on the first column, and then you look at the top 0.05. And then if you're going to draw the line on it, so the meeting point will be 0.8944. Okay, you will see that 0.8944. All right, so meaning to say it's 89.44%. Now, in the applets, we calculated 0.8944 as well. Okay, so we got that. Sorry. And then we got another one in the calculator. We got 0.8944. So we got the calculator, we got the applets. Actually, this is this is standardized, this is unstandardized. Okay, so that's the difference between the two. All right. So I hope it is clear, no, that we get this from the table, the 0.8944, and then this is from the applets. Okay, I'll show you the applets. Okay, so from the given applets, we're going to do that in the applets. Alright. So we got this one, where's the applets? Stoplets. So we use this Okay, so click the normal distribution. Alright, so normal curve, it should be 0, it should be 1. No? And then we plot it. So we plot that one, and then, so this should be left, no? Because we are on the left side, okay? So we are on the left side. Then the value is 1.25, right? So that's why we got that. All right, you see it? So we get 89.44%. So that is for the left side. Okay, see how easy it is? So here, okay, let's go over, let's repeat it again. So we go to stoplets.com and then go to normal distribution. We got 0 here, we got 1. Where's the 1? So we got 1 there. Okay, so 0 and then 1. The mean is 0, the standard deviation is 1. Plot. Okay, you will see this. Okay, the next one, click left, to the left. Then, right here, 1.25. Then, calculate 89.44. So, we can get that one in the applets as easy and as simple as that. Okay? So, that is what we do in the probability and statistics here in Richland 2. Okay? So, the next step, going back. So, we get this already. We go back. So this is unstandardized, no? So this is represented in unstandardized. So let's use this one, the unstandardized, so that you will see the difference. So we got the mean 165 and then 3. 165 and then 3, okay? Okay. So let's open a new one so that you will see the difference. So I'll be having here 165. This one is 3. Alright, plot. So you see that? So you got the values here. Now you go to the left. And then what's the value here? What's the given value? 170. So you got 170 here. Alright, 170 is the control variable. Okay, so you got 170. Why is it that's different? 170 to the left. Wait, why is it we got 3? It should be 4. Okay, so we got it wrong. It should be 4. Alright, so it should be 4. Okay, so correction. Okay, let's repeat it again. So 165 for the mean. For the standard deviation, then you click the button, this will appear. Then to the left, 170. Then you got, click the button, 89.44. You still get 89.44 from that. Okay? So that is for to the left side. Alright? Alright, next. So the next part is the interpretation. So about 89.4% of cars of this model would be able to make an emergency stop within 170 feet. Okay? Or you can say that it's approximately 89.44% that this model car can stop within the 170 feet. So you can do that. It depends on how you're going to state your interpretation. The most important is you mentioned the 89.44% and the within 170 feet. Okay? Next. What percent of cars of this model will be able to make an emergency stop in less than 145? So this time 145. So we look for the C score, -5. Alright. So as you can see, there's only -3.4 or 3.6. We don't have -5. Meaning, this is very, what do you call this one? This is usually, this one should, usually that didn't happen, no? So this, the value is very thin. In the normal curve, you cannot almost see the difference of this. Okay? In the mathematical presentation, we only have 3 to the right and then 3 to the left. We don't have -3 to the right or to the left. Okay? So you see that? We don't have that. But if you got that calculation, then there's something wrong. But according to the calculation, it's negative, so we don't have anything to do with that because it's according to the value. It's based on the value, but that is very minimal to happen, no? So we don't have -5 until -6 only. I think it's the most, no? All right. So what proportion of Gary and Jana's 7th grader have scored at least 9? Okay, so as you can see, guys, we are now on at least 9. The word is at least 9, or 9 or more. 9 or more. Okay, so in this part, we can say that it is to the right. The diagram here now is to the right. Okay, so in the second procedure, or we have the second objective. The second objective is find the proportion of the values to the right boundary of a normal distribution. So again, what we do, draw the line, we get the we draw the line and then we get the values. Okay? So we add 1.55 to the right and we subtract 1.55 to the left. Okay? Then we locate the 9. So after having this diagram, we go into the standardized picture. Okay? Because we calculated the z-score. So the z-score is calculated now. We got 1.39. You cannot get this without the z-score. Again, you cannot get this picture without the z-score because this will be the allocation of the z. So meaning these are the z value. Okay, the z-score. So we got 1.39. So approximately it's more than half, less than half of the gap between 1 and 2. Okay. So the next part, we still use the table, the transmitted table. 1.3, okay, then the 9, the 0.9, see that? 0.09, and then we got 0.9177. So, upon getting the z-score 1.39, we use again the transmitted table. So the first thing first, we check the 2 digits. So the first 2 digits, the 1.3. So we got that, 1.3. So it's here now, 1.3. Then we look into the third digit, the 0.09. So 0.09 is here on this side. Alright? Then, so upon moving it to the right and then moving it down. So they meet at 0.9177. So the value now is 0.9177. So that's very big area. We're going to notice our previous data is too small, no? So the area, the shaded area is too small. This is too big for 0.9177. In that case, the 0.9177 is the unshaded area. We can safely say that that is the unshaded area because that's 0.9177. Going back with the table, we got this value, the 0.9177, and then what we do now is we subtract the 0.9177 to 1. Okay, so we subtract it. Why? Because the complete normal distribution is equal to 1. The right side, from the mean to the left side, it's 0.5. From the mean to the right side, it's 0.5. 0.5 to the right, 0.5 to the left. So all in all, that is 1. Or we can say that it is 100% area. Alright? So that's why we got 1 minus 0.9177. So then we got the total score now as, this is now the area, the value of the shaded area, 0.0823. Or we can say that it is 8.23%. Okay? So this is now 8.23%. The same as this one. This is 8.23% as well. So these two is the same. Okay? While this one is represented only in an standardized normal distribution, while on the right side, it is the standardized normal distribution. Again, the difference is that we use the given value here or the row score, while here, we use the z-scores. Okay? So we use the z-scores in this area. Alright. So don't forget that the value or the area is to the left once it's stated less than. Once it is greater than or at least or number than or more, number or more, so the statement will be number or more, then it is to the right. Okay? So those are the two things, no? So the two things that you have to remember in identifying the shaded area, okay, of the normal distribution. So once it is the value, you have to look into the shaded area. Again, it's stated here to make you not on the mistake, so you're not going to do the wrong way. The first thing first that you need to do is draw the normal curve. Shade the area so that you will see if it is bigger or smaller. If it is smaller, of course, it is closer to 0. If it is bigger, it is closer to 1. Okay? So that's why you have to look into that. Okay? I know that you know already how to shade the areas, but this time, we are going to use those shading areas to the computation of the area, the complete area itself. Okay? The next one will be also regarding, as you can see, this is the 0.9177. So then this is the 8.23. So if we add these two, okay, that is 1. Okay? Now, there's another scenario that happened, no? So we got here, can Rory clear the trees? So when professional golfer Rory McIlroy hits his driver, the distance the ball travels can be modeled by a normal distribution with a mean 304 yards and standard deviation 8 yards. So these are the given. We got a mean 304, standard deviation 8. Okay? On a specific hole, Rory will never to hit the ball at least 290 yards to have a clear second shot that avoids a large group of trees. So he need to be at least, meaning if you say the word at least 290, it's going to the right, meaning 290 above. Okay, so it's 290 above, so meaning the shaded should be to the right. Okay, to the right. What percent of Rory's drivers travel at least 290 yards? Is he likely to have a clear second shot? So that is the question. Is Rory McIlroy can hit the second shot or not? So we have to look into this kind of scenario if he can hit the 290, at least 290, no? 290 above. Okay, so we're going to check if Rory McIlroy can hit the second chance. Alright? So if he can hit that, then it's good, right? So now, what we're going to do, of course, we need to draw the line, calculate the number line, and then shade it. So 290 will be here, so we shade to the right, okay? So we do the allocation of 290 in this area, then we shade it. Okay? The next part will be, we calculated the z-score. Okay? The 290 is the value, x value. The mean is 304. The standard deviation is A. Okay? And then the final answer is negative 1.75. Again, what have we done? We get the table and get the value. So the value will be from the table. Using your table, don't forget, we get this 0.0401. We get this from the table. Then we got 1 minus this value, that the one that we get from the table. Okay? So now, this value is 0.9599. Obviously, that's correct. Why? Because this is bigger, no? So the value is closer to 1. So 0.9599 is closer to 1. So that's why that's correct. That's the area. Okay, we can simply say that it's correct. That's the answer for the area. Okay? In the applets, we also have 0.9599. Okay, and then in the that is the standardized. In unstandardized, we still have 0.9599. Okay? So all in all, they have the same answer. Okay? But it depends on the teacher. They're going to ask you to calculate it on table or on applets. Okay? Me, I ask my student to use the table. But they can use applets for checking only. Okay? Alright, so we can simply say that about 96% of Rory McIlroy drives travel at least 290 yards. So he is likely to have clear second shots. What does that mean? So meaning Rory McIlroy can still hit the second shot. Okay? So meaning he's consistent. Okay? He's a good golfer. So in that case, we can say that Rory McIlroy can hit the second shot. Okay? So meaning Rory McIlroy is consistent. Okay? He can still win in the game. Alright? Next. So we are now done on the objective number 2. Okay? Finding the proportion of the values to the right, okay, of the normal distribution. So what proportion of Rory McIlroy drives for exactly 290? So because the point of the number lines has no width, there is no area directly above the point 290. Under the normal density curve, in the obvious example, so the answer to our question based on the normal distribution is 0. So meaning he can still hit the second shot. Okay? Now, so how do we find the area in a normal distribution that is between? So this time, we are now on the third objective. Okay? So how are we going to do? So it's between now, okay? So now the example will be between. So having the value, so we got 6 here and then 9. This time we got 2. We got the lower boundary and then the upper boundary. Earlier we just have the lower boundary, meaning the boundary going to the left and then the boundary going to the right, okay? This time we have the left and we have the right, but the shaded is in the center, okay? So that is the other issue or the other things that we have to calculate. So now, what we do now is, of course, we're going to calculate the z-score, okay? We calculate the 2c score because we have to the left and to the right, or meaning lower boundary and then the upper boundary. We calculate those c. So this is the lower, this is the upper. Okay, the left side will be the lower and the right side will be the upper. Okay, so we calculated 6 minus 6.84 divided by 1.55, then the final answer is negative 0.54. The other one, we got 9 minus 6.84 divided by 1.55, the final answer is 1.39. So we get these two to get the figure or the picture or the graph that we need for the standardized normal distribution. So we get these from the given value. Okay, we calculate the z-score. Next step, we still go on to the table, but first and foremost, we have to know the allocation. How are you going to do with this? Because they are between, okay? So the first thing first, we get the bigger one, okay? And then we subtract it with the small one, okay? In the transmitted table, we don't have to the right actually. That's why we got 1 minus the value to the right. So in that case, we use all to the left, okay? So this is 139, we shade it to the left. This is to the left as well, a negative 0.49. Once we subtract it, we will be having this. Once we subtract, meaning it's just like eating a pie. Once you eat the pie on this portion like this is your target to be eaten, so this will be the eaten. And then that will be the left one, no? This will be the portion that will be left behind, no? Like this. Alright? So in that case, we got the area to the left of 1.39 minus the area to the left of negative 0.54. As you can see, the bigger portion or the positive portion is on the left side as compared to the right side because that is bigger than this. Alright? So now we get the values of each area to the table. So we get the 0.9177 from the table. Then we got 0.2946 from the table. These two values we get it from the table. Okay? Again, transmutation table. We get it from our transmuted table. The 0.9177 and 0.2946. So after getting it, we subtract it and we come up with the answer 0.6231 or 62.31%. So meaning the area here is 62.31%. Now, using the technology, we still have that 62.31 and then 62.43. You see the difference? So the difference between the two, actually the three, is approximately very minimal. No, the difference very minimal. So we can simply say that about 62% of Gavi in China 7th graders earn grade equivalent scores between 6 and 9. So they got 6 and 9 only. These are 62%, meaning that is too big, no, for their test. Okay. So notice that the answer of the obtained using standardized score is 0.631 is different from one obtained directly from the unstandardized division ITBS vocabulary score 0.6243. Due to the rounding the scores to 2 decimal places, they got the same answer. Alright? This is another problem set for Rory McIlroy. Okay? So, on another golf hole, McIlroy has the opportunity to drive the ball onto the green if he hits the ball between 305 and 325 yards. What proportion of Rory drives travel distance that falls into this interval? So, we're going to look into how many percent can we get from this proportion. Okay, so what we do is, of course, we draw the line, we get the curve, okay, we got a normal curve, normal distribution, we plot it, okay, this unstandardized, alright? Then we get the table, we calculated the z-score, so this is the z-score to the left, to the right, this is to the right, this is to the left, this is to the right, okay? So we get that values, okay? So then we got 0.4440 on the table. Alright? By the way, we get this first. So this will be here, 2.63. We get it from the table. And then 0.13, we get this from the table. And then we got that. So we subtract it. Then we got 0.4440. The same as in applets. This is standardized, then we got unstandardized. So you see the difference, 4459, 4440, 4440. So approximately they are closer to each other, okay? So what we did now is we can say that about 45% of McIlroy drives travel between 305 and 325 yards, okay? So now, this is an activity for my student to work on. So, until next time, I'm going to give you another example. Maybe on the next episode, I'm going to solve this one so that you can see how are we going to solve this problem set. Bye-bye. See you in the next episode.